Assalamualaikum. Hi guys. In this video, we are going to learn how to illustrate or describe the hybridization for several examples. In order for us to describe the hybridization process for a specific molecule, we have to follow several steps. The first one is we have to draw the Lewis structure no matter what. And the second one, you have to predict the molecular geometry. Write the electron configuration for the central atom because we are going to focus the hybridization for central atom only. This is where we are going to determine the ground state of the valence electron. This means that that atom doesn't donate or accept any electron. That's why it is a ground state. Next, you have to promote the electron to possible hybridization state. At this part, we are going to excite the packed electron to make it as unpacked electron. However, it is not necessary for all molecules, so we have to take a look very careful about this one. And last one, we have to hybridize the orbitals accordingly to their hybridized state. So if you take a look here, there are quite a lot of steps here kan, nampak banyak. Don't worry, we are going to do it step by step. We will only discuss the hybridization and draw the overlapping orbital for these following compounds. So I'm going to separate into two parts. So in this video, we are only going to focus with the first part, only for this one. And this one is for the second part. So let's start with CH4. We are going to calculate the total valence electron first because we need to draw the Lewis structure for CH4. I have carbon, 4 electrons, 4 hydrogen means that 4 electrons, and then the total will be 8 electrons. Next, I'm going to draw my central is carbon bonded to 4 hydrogens. So I have 4 of them, and I use up already 8 electrons here, so that's why it becomes 0, no more left. Now, we are going to label the sigma bond for CH4. So we have 1 here, 1, 1, 1. So the total will be 4 for the sigma bond on carbon. And next, we take a look at the lone pair around carbon. There is no lone pair, so that's why the total will be 0. So from here, the total will be 4. And remember, we have to determine the type of hybridization for central atom, in this case, which is carbon. I've taught you in the previous video, we have SPP, 1 shape for S orbital, 3 shapes for P orbital, and we have 5 shapes of D orbitals. So you can see that from here, I use up 4. So maknanya saya akan ambil daripada S dan 3P. So, when I combine all of them, dia akan jadi sp3. So, this is the type of hybridization for carbon in CH4. So, to make it much more easier, I'm going to label this one. Tunjuk anak panah ke arah carbon sp3. Next, we go for the next step. We have to write the valence electronic configuration for carbon at ground state. So carbon at ground state, dia dalam period 2 with 4 valence electrons. So I'm going to write down 1, 2 for the electron, and I got 2 more. Follow the Hans rule. So in this case, you can see that kita ada 2 unpacked electrons. So these 2 unpacked electrons can only form 2 covalent bonds ataupun 2 sigma bond. Tapi sedangkan kita nampak sini, kita ada 4 sigma bonds. So macam mana kita nak hasilkan 4 sigma bond? Kita perlukan 4 unpacked electron. So that's why we are going to excite the electron. So from here, I'm going to excite one of the electron in the 2s orbital and put it into this orbital 2p. So we can get the next carbon at excited state with 1 electron in 2s and 3 electrons in 2p. Now, the next step, we are going to show the carbon at hybrid state. Dalam kes ini, at excited state, energy of the orbital tak sama. Sebab kita ada orbital 2s, kita ada orbital 2p. Kalau ingat, shape dia pun berbeza. Satu spherical, satu dumbbell. That is why kita kena buat hybridization. So dalam kes ini, kita akan tunjuk carbon at hybrid state, di mana 2s orbital dan 2p orbital akan mix together to form sp3 hybrid state. So di sini saya akan kumpulkan semua 4 unpaired electrons here sebagai sp3, and each of them ada satu unpaired electron. So maknanya di sini kita sudah dapat 4 equivalent energy of sp3 hybrid orbitals. Ada 4. And next, kita dah settle untuk central atom. Central atom kena tunjuk full for hybridization process. Maknanya kita kena tunjuk carbon at ground state, carbon at excited state dan carbon at hybrid state. Now, we go for the terminal atoms. Terminal atom kita adalah hydrogen, sama untuk all of them. So, what we're gonna do, kita hanya tunjuk hydrogen atom at ground state only. Dan kita faham, ground state dia hanya ada satu elektron. That is why dia akan ada one unpaired electron here. So, apa yang dimaksudkan dalam kes ini, kita akan faham, kita ada 4 hydrogen. So, satu elektron ni akan overlap dengan one of the electron in sp3 hybrid orbital. The second hydrogen with this one, the third hydrogen with this one, and the fourth hydrogen with this one. So that is why kita dapat 4 sigma bonds. Now we are going to continue the next step, how you want to show the orbital overlapping. This is where you need to draw. So kita nak draw apa? Kita nak draw sp3 hybridization for carbon in CH4. So we got carbon, dia punya type of hybridization sp3. As I mentioned before, kalau sp3, dia punya orbital arrangement mengikut basic shape adalah tetrahedral. So, saya akan draw daripada tengah. So, from here, saya akan buat dotted line dahulu. Sebab saya nak tunjuk tetrahedral punya bentuk. So, kalau awak lihat kat sini, this is my dotted line for tetrahedral. So, I'm going to draw sebagai tetrahedral ada 4 loops untuk sp3. So, I will draw my sp3 hybrid orbital right now. Then, saya akan label this one as sp3. sp3, sp3 dan sp3. Dan kalau kita lihat this one for carbon. So, ini adalah carbon dekat tengah-tengah. Next, we are going to show the orbital overlapping. Untuk hasilkan sigma bond, maknanya dia akan overlap end to end, hujung ke hujung. So, saya akan draw shape untuk hydrogen, di mana hydrogen kita ada ground state dia 1s. So, I'm going to draw 1s here. And then here, I got 4 of them. So, just draw 4 spherical shape for 1s. And then, I label 1s, 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 and 1s. The next one, bila dalam area dekat sini, dia akan share a pair of electron. So, saya akan indicate opposite spin untuk a pair of electron. Dan saya terus label sebagai sigma bond. Last one, jangan lupa label this one for hydrogen atoms. So now, you got the orbital arrangement untuk CH4 dalam bentuk tetrahedral because of sp3 hybridization. And then, molecular geometry stays the same, tetrahedral. And next one, bond angle. Untuk tetrahedral, kita ada 109.5 degree. So, macam mana saya nak label untuk drawing ini? Kita kena faham bond angle adalah antara overlapping orbital. So, maknanya daripada sigma bond here kepada sigma bond here, saya akan label sebagai bond angle 109.5 degree. So, settle sudah untuk describing the hybridization process in CH4. Let's try the next molecule. Kita ada H2O. So, calculate the total valence electron first. I have 2 hydrogen, means 2 electrons. And then oxygen, I have 6 of them. And then the total will be 8 electrons. And then bila saya nak draw the Lewis structure, oxygen as my central with 2 hydrogens. And then saya dah guna 4, so minus 4, you got 4 more left untuk 2 lone pair di central atom. And next, kita akan calculate number of sigma bond dan lone pair untuk tentukan type of hybridization. So, saya akan label dulu sigma bond saya. Di sini, saya ada 1 dan 1 sigma bond. So, kalau lihat total sigma bond on oxygen, kita ada 2. So, I'm going to put 2. And then number of lone pair, you can see that on oxygen, we have 2. So, the total will be 4. And right now, as I mentioned before, kita ada SPP, DD. So, bila 4, kita akan guna sampai SPPP sahaja. So, dia akan jadi SP3. And then, saya akan label lah dekat sini. Ini adalah SP3 untuk oksigen. Next, kita akan show the hybridization process di mana you have to show oxygen at ground state, at excited state, and hybrid state. Let's do it one by one. So, oxygen is in period 2 and it has 6 valence electrons. So, I'm going to put 1, 2, 3, 4, 5, 6. And right now, kalau awak nampak dekat sini, kita perlukan 2 sigma bond, maknanya 2 unpaired electron. So, kalau lihat, kita sudah ada 2 unpaired electron. Maknanya, ini akan form with hydrogen sigma bond. So, apa yang akan terjadi untuk another 2 here? Another 2 here yang ada paired electron ini, dia merujuk kepada 2 lone pairs yang ada dekat oxygen atom. So now, kita nak continue at excited state. Do we have to excite anything? No, because we got already 2 unpaired electrons to form the bonding for sigma bond. Maknanya, untuk excited state, masih kekal macam this one. Sama sahaja. And then, the next one, kita tahu energi untuk 2s dan 2p tidak sama. That is why we are going to mix this orbital. Melalui proses hybridization, kita akan guna semuanya sebagai sp3. Sebab kita dah tentukan sp3 tadi. So, I'm going to copy back 2 electrons, 2 electrons, and then 1 electron, 1 electron. Dan dalam kes ini, kita akan ada 4 kotak untuk sp3 hybrid orbitals. Satu lagi tips yang awak kena faham, when we want to do excitation, kita perlu excite untuk dapatkan unpaired electron. Tapi nak excite, kita kena ada orbital yang kosong. Sebab tu dalam case oxygen at excited state, kita sudah ada 2 unpaired electron. Kalau kita nak excite pun, kita tak ada ruang kosong dalam 2p sebab dah penuh. Sebab itulah, ground state dengan excited state for oxygen sama sahaja dalam case ini untuk H2O. And then, last one, jangan lupa kita kena show the hydrogen at ground state with 1 electron. Next, I'm going to show the orbital overlapping. Kita faham oxygen dia ada sp3 type of hybridization. So, we are going to start by drawing the tetrahedral shape for this orbital arrangement. So, I'm going to draw my tetrahedral. So, kalau tak boleh draw straight away, awak boleh dulu buat draft supaya awak draw cantik-cantik. So, saya akan buat draft bentuk tetrahedral dulu. Kalau boleh lukis secara jelas ya, secara cantik, boleh nampak. So, this is for oxygen sebagai central atom. And then, saya akan show the sigma bond overlapping orbital end to end. Bentuk hydrogen at ground state adalah spherical for 1s. So, saya lukis bulat. Sini pun bulat. And then, kalau lihat dekat sini, saya hanya ada 2 sahaja hydrogen. Maknanya saya draw dua sahaja spherical shape. Dan di sini apa yang awak nampak, you got here for your lone pair. So untuk case itu, saya akan buat lone pair di mana kita ada dua electrons untuk each loop. And then for this one, orbital overlapping ada a pair of electron. Dan jangan lupa label this one as 1s. And then kita ada for hydrogen, both of them. And then next, awak ada two electrons here yang overlap antara sp3 hybrid orbital dan juga 1s orbital. So dekat sini kita akan form sigma bond. Okay, boleh nampak kat sini. And last but not least, you have to label the bond angle. So bond angle adalah daripada sigma bond kepada sigma bond. I'm going to label from here to here. So, untuk angle for water, kita tahu dia ada specific value yang saya minta awak hafal. Instead of kita tulis 109.5, kita guna exact value for the angle of water, which is 104.5 degree. And then, orbital arrangement for this one adalah tetrahedral, because we got sp3. And then, molecular geometry for water, sebab dia ada lone pair dekat sini, ini adalah untuk two lone pairs. So maknanya kita tahu dia akan berubah menjadi band ataupun V shape. And the bond angle mesti tulis yang spesifik sebab ini water. So you have 104.5 degree. Now let's go with the next example. We have BeCl2. Nak tak nak kita akan draw the Lewis structure first. So Lewis structure kita akan ada Be bonded kepada Cl sebanyak 2. So this is the Lewis structure where I'm going to label my sigma bond. I have one here and one here. And then kalau lihat dekat sini, number of sigma bond on beryllium kita ada 2. And then number of lone pair kita ada 0. So we can total up, which is 2. Bila 2, dia punya type of hybridization on beryllium adalah sp. 2 saja kita guna. So dalam kes ini, awak boleh label this one as sp. However, dalam kes ini, awak nampak kita ada terminal atoms di mana dia bukan lagi hydrogen tapi dia adalah Cl. So bila Cl, awak juga boleh tentukan type of hybridization for Cl, di mana Cl ada 1 sigma bond dan 3 lone pair. So bila 1 sigma bond dan 3 lone pairs, maknanya, and same goes for this Cl, sp3. Now we are going to show the hybridization process only for the central atom. So central atom kita adalah beryllium. So saya akan draw the orbital diagram untuk beryllium at ground state dahulu. So beryllium kita ada 2 valence electron. That is why I have a pair of electron in 2s orbital. Next one, as you see here, we got 2 bonding. Bonding untuk dapatkan sigma bond, maknanya kita perlukan 2 unpaired electrons. That is why kita akan add side. Dan kita ada empty orbital 2p here. So I'm going to add side 1 electron from 2s into 2p. So saya akan dapat 1 and then 1. Now you can form the 2 sigma bond, di mana dekat excited state ni kita akan mix these 2 orbitals together. Awak boleh tentukan type of hybridization for Cl is sp3 sebagai sp. Dan dalam ini kita ada 1 elektron each. However, apa yang terjadi dekat selebihnya, kita akan split them sebagai empty 2p orbital. Mesti label dan gunakan perkataan empty. So, settle untuk hybridization process for our central atom, beryllium. However, untuk terminal atom kita dah tentukan type of hybridization is sp3. Tapi, for your matriculation level, you don't have to show sp3 dalam bentuk tetrahedral for terminal atom. Hanya gunakan ground state sahaja untuk terminal atom. So that is why dalam kes ini saya hanya tulis chlorine at ground state with 7 valence electrons and in period 3. So I have 1, 2, 3, 4, 5, 6, 7. So di sinilah saya ada one unpaired electron yang akan overlap dengan satu daripada sp, dan another one unpaired electron from another chlorine akan overlap dengan another one electron from sp. That is why awak akan dapat 2 sigma bonds. So kenapa saya letak chlorine at ground state sahaja, saya tak show chlorine at excited state dan hybrid state? This is because there is no mark for that one. So we just try to make it very simple for your matriculation level. That's why we don't even need to show the hybridization process for Cl. Now I'm going to draw the orbital overlapping. So as I mentioned in the previous slide, Be dia ada type of hybridization sp. Kalau sp, dia akan adopt orbital arrangement sebagai linear. So bila linear, kita akan buat bentuk sp secara melintang ataupun horizontal. So I'm going to start with the first one. And then next, saya ada chlorine. Kalau ikutkan previous one, chlorine dia ada dalam 3p orbital. So 3p bentuk dia adalah dumbbell. So maknanya saya akan draw another dumbbell sebelah kanan dan sebelah kiri untuk hybrid orbital of beryllium. So saya akan letak end to end sebab nak form sigma bond. So ini adalah 3p. Label salah satu sahaja, macam awak label orbital dulu. Salah satu saja, tapi kalau untuk hybrid orbital kena dua-dua loops ni. Okay, now we go for electron. Dekat sini kita ada a pair of electron dekat orbital overlapping ni dan kita indicate sebagai sigma bond. And then the next one, this is for chlorine yang pertama sebelah kanan dan this is for chlorine yang kedua sebelah kiri. Next, kita tentukan molecular geometry. Kerana dia tak ada lone pair dekat central atom, so molecular geometry sama sahaja dengan orbital arrangement, which is linear. And the bond angle, dalam kes ini bond angle adalah antara sigma bond dengan sigma bond. I got linear, so maknanya the angle will be from here to here. The value is 180 degree. So this is the orbital overlapping for BeCl2. Dan ingat, kita hanya tunjuk hybridization for ground state sahaja untuk terminal atom. Yang central atom ni kena tunjuk semua, the whole hybridization process. Ground state, excited state dengan hybrid state. So you can write the bond angle which is 180 degree. So I'm going to stop here. We are going to continue for the next example in the next video. Thanks for watching. Bye.